Hey folks, Azure Cosmos DB TV. Welcome. I'm Mark Brown, and I've got with me this week special guest David Aronchick from Expanso. David, how are you?
Great. Thank you so much for having me.
It's great being on or having you on the show. We wanted to have you guys on to kind of show some of the cool stuff you're doing. I find this kind of a fascinating topic, and I see more and more of this or this scenario. And you guys kind of fill kind of a critical gap in what you do. I wanted you to explain kind of what Expanso is, what it does, the technology, and show off kind of what you guys do, and kind of give us a scenario in a real life kind of a scenario around this. And
absolutely.
So
absolutely. Thank you so much for having me.
I'm going to take it away. I'm going to bug you for the next.
No. Go ahead. I mean, it's funny. So, my background is I've worked at all the hyperscalers so far. I worked at Amazon. I worked at Microsoft twice. I worked at Google. My background is I used to lead product management for Kubernetes on behalf of Google. And, was there from kind of, very, very early. Not quite, Brendan Burns and Brian Grant and Tim Hawkin early, but, pretty early. And then I started Kubeflow, so I was very deep into machine learning. But in all of these places, in all of these hyperscale clouds, I kept hearing the same problem over and over again. Hey, you know what? This is great. This declarative rollout of this infrastructure is great, but it turns out that we have, multiple data centers, multiple regions. We're following our best practices according to the SEs. Hey, we need to roll out into these various locations. How do we do that in a broad and declarative way? In the same way that we do through Kubernetes or Databricks or Hadoop or anything like that. What's the path for doing that? And it turns out there really isn't one. There are a bunch of really famous stories about people spinning up, literally a Kubernetes cluster, per whatever car or per satellite or per retail outlet. But that's a really weird and let's call it bad pattern, because it only solves a little bit of the problem. It solves okay, I have my job and I want to run it there. Once I get the job there, then it'll run fine. But how do I reliably even get the job there? The description of the job. That turns out to be a big problem. One of the areas that we see the biggest problem is around data, right? So you think about physical infrastructure and these VMs spread all over the place. That's kind of a bad, sort of bad pattern, but at least you can kind of work your way around it. When you start to get to data, that's where things really become problematic. And the reason is because of stuff like this, right? Data is explode. And by the way, can you see the screen, or can you see the slides?
Hold on, let me put you. Sorry, let me put this up. Yeah, go ahead.
Oh, sorry. Yeah, absolutely. So the platform that we built is called Expanso, and it's really just helps solve, or this is the area we saw the biggest issue, where you have data growing at an absurd rate. IDC says 175 zettabytes will be created by or stored by enterprises worldwide. 60% of data is unstructured and outside of traditional data centers. When Gartner survey says 73% of people say that just keeping up with the data is not working. Now, a very traditional approach is to take all of your data and to move it into a centralized location. Yep. And again, that's not bad. No one's saying don't do that. But the problem is that that's not where the real world is. And last time I checked, the speed of light isn't getting any faster. And as a result, you are going to, wow, that's weird. You're going to run into this problem.
Faster either, by the way. So
what's that?
WANs aren't getting any faster either, right?
Exactly. Yeah. So, you're just going to run into this problem over and over again. Like if I put, a gigabyte in LA and I need to move it to New York, I can tell you in 100,000 years, the ping time is still going to be 49 milliseconds. It just is. There's no way to shorten ping time. unless you get to quantum tunneling and so on. So that's just the start, right? As you said, WANs aren't getting any faster. They're certainly not keeping up with the data. Even if neither of those was true, regulations are only growing. We already have things like GDPR and CCPA, but like industry-specific regulations. So the moment you begin to move the data, that's where you begin to run into problems. And these two things about the data being global, data being generated globally, and the difficulty in moving it into a centralized data center, it's going to add risks and bottlenecks. And so being smart about how you adjust that is really important, and something that people are going to have to take on in the short term.
This is you did a great job kind of laying this scenario out, and this is exactly what I see on our end on Cosmos is, look, the cloud is democratized creating these resources everywhere on the planet. So people are wanting to go cloud scale, global scale, and they're generating data in all these locations. And you're right, they could go and try to pipe every single bit back into a centralized data center and then start doing something with it. But that's a lot of data to be piping over the internet, and not all of it necessarily needs to be there. And frankly, a lot of it needs to be processed and managed locally. Like you were saying, there are going to be data residency and other laws like this and regulations in place. And having a way to be able to distribute data in a distributed fashion, I think, is kind of a key niche and a key market, a key area. And this is kind of, anyway, I'll shut up and let you keep talking. But
no. I mean, my God, I know you're very happy on Cosmos, but if you'd like to come be our advocate, you're doing a better job than I am. So absolutely, I couldn't agree more. And this slide, I always like to bring this up. They're like, oh my God, are you gonna tear out my Cosmos or my Redshift or my Databricks or my whatever? Nope, no. Keep it. Those run great. They solve a key problem that you have to solve. So keep at it. The problem is, most folks, when they're thinking about their data pipelines and their ETL and so on and so forth, think about this right hand of the slide, right? And they're like, all right, well, I'm going to pick this thing and I'm going to build this stored procedure and I'm going to build this blah, 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 blah. And very few think about this left-hand side. What do I do? Multi-region, multi-cloud, edge, IoT, on-prem, embedded, and so on and so forth. And most of these folks just don't have, most of the folks on the right are like, well, we're going to leave that as an exercise to the reader. And it's not because they're mean. It's just because everyone's got a different way of approaching that. And so they're like, well, look, you think about it. We're here when you decide. Does that all make sense?
Yeah. Yep.
So what we do is we have an open source platform called Bacalhau, and we are the company behind it. And what we do is we enable you to run your jobs in various locations. And that doesn't mean replacing those central data centers. It means being smart about managing, transforming, schematizing, whatever it might be, your data before you move it. Because if you're moving it raw, then you're probably doing something wrong. You just are. You're losing stuff, and I'll get to this all in the demo in just a second. But that's what we try and do. And if you do that, if you adopt a platform that enables this, and I think it's a general direction the industry is going to go, called compute over data. If you enable this, then you're going to enable doing things faster because you don't have to move the data before you take action. It's going to be cheaper because you're going to move less data. You're only going to move what you really need instead of every single bit. And it's going to be more secure because you're now able to process some of that data or remove privacy or other things before you move it. And so what that means is again, I know that we're a platform. Again, we want to work in collaboration with all these folks, which is exactly why we're on with Cosmo TV. But we run in all of these places. It's a distributed platform, very similar to the experience you might have with Kubernetes or Docker or something like that. But you name where you'd like it to run. You'd like it to run multi-region. You'd like it to run multi-cloud. Oh, I got to do this, and it's got to be really low scale. So it's got to run on a Raspberry Pi or some very low power device. It's got to run embedded, so on and so forth. And we give you that flexibility to execute that job by sitting in front of your existing infrastructure, not replacing it, in front of. And because of that, your entire pipeline just becomes cheaper and faster. Does that all make sense?
Yeah, that's I mean, you're your own best advocate there. You put it much better than I do. So It's exactly right, and this is a key. Like why I like what you guys do, and I think this is an interesting. Customers are running Cosmos because they're running in multi-region, and
Absolutely.
And so there's an interesting matchup here with our two services. So, okay.
Absolutely. Absolutely. So to talk about this, let's talk about it. Cosmos DB for edge data collection. Again, a lot of people are just kind of like, well, how hard could it be? It's just edge, right? These are low power devices. All they do is spit out something. What's the big deal? And the net of it is this slide, I like to think, right? Cosmos can scale. There's no question about that. And I'm going to demonstrate it in just a second. Like, I'm going to demonstrate something that, 10 years ago would have been nigh on impossible. And I'm going to do it, just showing how powerful and the throughput and so on and so forth. And what I like to say is, Cosmos can scale, but data and networks can't because they're raw. You need to do work at the edge or before you move it. And so what I like to say is, by doing, the pain points are going to be cost and performance and complexity, all that stuff. You're layering that on by waiting until the end of that right-hand side of the data pipeline to do this processing. If you can be smarter about it and do some, not all, some of that processing, remotely, but do it in a declarative way where you're not adding complexity, you're going to make it more efficient. You're going to reduce your spending. You're going to speed insights by a lot. And you're going to reduce your overall operational overhead. So what does this look like? Well, so before we are on the scene, it kind of looks like this. And again, these are just kind of made up things, but it's going to be very close to the demo I'm about to show you. Let's say you have a retail outlet or a factory or so on and so forth. And don't even think like, oh, well, I don't have any IoT. Guess what? If you have a machine somewhere in the world, collecting, I don't know, video data or thermostat data or whatever, just because you want to have overview, congratulations. You've joined the distributed computing club and you're going to have to deal with that data. But in this case, let's say we have retail with each of which have a sensor in a corner. Maybe it's detecting human movement. Maybe it's detecting thermostat or temperature changes. Maybe it's a factory floor that's detecting humidity and pressure of that particular room. You name it. All that data today, I have bad news for you. It is incredibly poorly structured. More often than not, it's a single string of data with nothing else there. It doesn't know where it was placed. It doesn't know its name. It doesn't have a unique anything. It's just a string of data. And you're like, well, I better do something with this. And a lot of people just take it and they push it into their ETL. And they're like, okay, well, I'll fix it once it gets to my centralized ETL. But then by just moving that, you've all of a sudden started to lose data, right? You didn't know where it was sourced from, what time, what the local time was. Is this on GMT? Is this on local? You don't know exactly where in the factory that might have been placed. There's a whole bunch of metadata you're losing just at that moment if you don't record it. And then even if you do record it, even if you did have it, you're now dealing with, something where, I'm very old. So I remember when factories, were lucky to get like a ISDN line. But, nowadays, even with a cable modem, that thing could go down for, 20 minutes. Happens all the time to me at home, at least twice a week. Do you lose the data when if it's only connecting and pushing that back? Do you lose that data? Is there a more elegant way to stream that data in? All that kind of stuff. Once it gets to your centralized, data warehouse, it's probably storing too much. And this is really the worst. Cosmo can process things lightning quick. And again, I'll show you that in just a second. But if I need to wait for it to go through my entire ETL and my entire upload and my entire everything before I can take action, well, that ain't great either, because at least that's going to be minutes if I'm lucky. And there are plenty of people I've spoken to, customers who are talking about saving weeks of time before it makes it all the way through their pipeline. Does that make sense?
That's kind of an insane amount going on there. But you make a good point. Like if you got an opportunity to enrich the data, or if you need to enrich it, you should before it's send it. In some of the cases, that's going to be exactly all that stuff you're talking about there. And absolutely. Latency is key. Like, bandwidth is relatively cheap, but it's still, that still adds up. And also, the heavier the payload, the longer the latency. So you want to keep things
Exactly.
fast, right?
Exactly right. So, so what a different architecture we propose is this, right? Again, remember, you're not changing this. You're still using and loving Cosmo. You're using your existing ETL, but we call it what, kind of near compute is what we're calling it, right? And basically what this means is you take your IoT or other data and you push it into a local store. Could be just a file like Parquet or SQLite. Could be something richer like an iceberg table we have here. And then you have near compute, which sits over the top of that. And then what this does is it reads in from that local information and wraps it in metadata and has a much more reliable way to push the data up. And by doing that, if there's intermittent connectivity, if you want additional metadata, so on and so forth, everything is streamlined. It lands in your ETL pipeline as is. It doesn't land at kind of stage 0. Let's say you have a 12-step ETL pipeline. You're now going to land at whatever stage 4 because you've done a bunch of the transformation already. And just doing that, it speeds things, it accelerates your understanding, certainly saves money and time and so on and so forth. All kind of for free. And by the way, if you do it this way, then let's say you have something really emergency happening and you're like, I need to go query this like I would a regular table. You can do that too, right? Because you're storing it in a, queryable format with that metadata in those remote machines. And that's something our platform enables as well. So that's kind of the broad strokes. I know I'm a watcher of this show. I know that the real fun begins with the live.
That's right.
Panicky download. Do you have any other questions?
No.
I'll give you the overall architecture of what you're about to see, and then we'll dive right in.
Okay.
Sorry, I talk a lot. So the architecture is really, 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 really straightforward. Okay, we're going to have a bunch of sensor data. In this case, we're going to have about 300 sensors spread all over the world across 26 cities, if I remember right. Each one of them are writing to a local file on a machine called sensordata.db. They all hand their data, or then you have a application written in C# called uploader. Cosmos uploader is what I called it, and it uploads into Cosmos with the city as a partition. Now, again, I know it's such a sensitive topic. How do you choose your partition? Well, look, we arbitrarily chose the number of cities, so and the number of sensors, so we evenly spaced it out. But that was the split we chose.
At least you took that into consideration, David. So thank you very much.
Fair enough. So the reason we chose this, the reason this is so much more powerful than IoT just going straight over here, is because you now have the ability to do configuration in this uploader and be much more reliable with your overall uploads. And the way you're controlling all of these various things is with our agent, which is going to be deployed on that machine across 300 different nodes. So let's say I want to change something in the configuration here. I can deploy to this job, and this goes and changes that. Let's say I want to do some firmware. I can do that too through our overall OS, through our agent. The agent is really, really lightweight, and we are absolutely neutral about what you decide to run. I'm going to show you running all kinds of crazy things here in just a second. So this is the architecture. I'm going to come back to this a couple times. I just wanted to lay it out for you ahead of time. Okay. Let's get to it. So, all right. What demo would be complete without VS Code up and running? So what you see here is our uploader. I'm going to give you the lay of the land. Over here, you have our real live sensor dashboard. This is uploading all through our Cosmos DB. In this case, we're doing 100 sensors. I'm sorry, we had a different one that was 300, but we're doing 100 sensors spread across 33 cities. Okay. And in each one, you can see we're collecting temperature, humidity, and pressure data. Okay. Pretty straightforward stuff. Nothing, too tremendous here, but like all this data is coming in and it's flowing in real. This is all real live running data against Cosmos. And again, just to show you, I gave away the thing here, but you can see this data right here. This is real live Cosmos data flowing in as we speak with our different sensor readings and so on. Okay. Now, the problem to start, and to give you a layout here, I am running this over, we have a cloud-based system for doing the orchestration. All the nodes run on-prem, so they are completely separate. This one happens to be running through a cloud instance. And again, but lots of folks run with this entirely on-prem with no cloud instance. We're extremely easy to deploy.
So it's Expanso. So your stuff, you can deploy nodes on-prem and just have them sit there running by themselves. Or
you can deploy your network on-prem. This is right here. Let's say I want to create a new network here. Yeah. All I do is I create that, and it'll give me instructions to either use the one on the cloud or download and run it myself.
Got it. And then with your own network, you get like a assigned range of IP addresses and then addressable within that, and then all your nodes deploy into that.
So one thing that's really interesting is we don't take any opinion about the we don't take any opinion about the network. We kind of rely for you to show up and say like, okay, all your nodes need to be able to see each other. They don't need to see externally. They don't need to do any kind of public interaction or DNS lookup. You can use your own everything. But we do expect you to have a TCP connection that goes between the various connection points.
Got it.
Does that make sense?
Yep.
Okay. So here's the Cosmos uploader. And again, all this is open source code. You can go like hack at it, mess it around, prove me wrong. But to show you what it's like to add a node, all you would do is you would go here. And again, you'll get this. You just come to our website, cloud.expanso.com. You get these instructions. It gives you a config. And then on any given node, you just type this. And that's it. That is the entire thing. I love Kubernetes to death. You'll never hear me speak ill of her. But like, let's be clear. Setting up Kubernetes is not this easy. Okay. So let's start. So we said already what's going on here. We have, thousands of data points coming through every second. What does that data look like? So this is really it. This is raw data. I happen to have given these sensors actual IDs, but this is basically it. A bunch of raw information coming through here. The pressure sensor, so on and so forth data. Not great. It's all landing inside of Cosmos as is right now. But that's really not what is ideal. What would be better is if we were at least schematizing it, right? So what would that look like? Well, we're going to pop over here. I have already written a schematization processor, okay? So what this does is it takes your flat text file from the raw thing, and it looks through and it just parses it, right? That's all it does. It parses it into items that are now fully schematized, and then we hand that to Cosmos DB. Now, you may say, well, wait a second, I'm handing this to Cosmos DB. Is this going to require massive schema migration? I'm going to have to do something crazy? Nope. Cosmos has got you. It's NoSQL. Every document is self-complete. All I need to do is add the fields I want, and magically it just shows up. Yep. So to show you that, we're going to actually get there and run it. And there we are. So to run this, let me show you what the job actually looks like to run a bacalhau job. We're going to go over here to schematize. This happens to be a Docker container. This one is a really stupid one, just because I don't know. I wanted to be very, very simple for the demo. Sure. But all it does is using Alpine, it changes the configuration of how it ingests in this configuration file. That's it. That's all it does. And it turns schematize off to schematize on. Now, like I said, I did a little bit of pre-baking here because I already had the schema processor built into the DLL. Maybe you want to build it ahead of time, or maybe you want to deploy a new one. We support that too.
I mean, users just take whatever their data is and whatever, get that into JSON, do it however you want to do it, and then
exactly
make that part of your basically your job.
Exactly right.
Yeah.
So now I'm going to go off and I'm going to run this bad boy. and running it is super straightforward. You can see there, I have it running super quick. And then when I go back over here to my job, the chart data stays the same. I got to refresh here. You have to blame the UI on me. Any slowness and things, don't blame it on Kubernetes, or excuse me, on back of the hour Expanso, blame it on me. But you can see here that all I did was I loaded the data, and now it comes in, and the front end is doing none of this. This is all back end data that is being processed. And when I go here, you can see I execute the query. You can see that the things are now appearing in schematized format. Make sense?
Yep. Looks good.
So super straightforward. All I did was push that job out there, change the configuration remotely, and then off I went. And like I said, we could do full DLL and other deployments. This happens to be really convenient because there are so many things being deployed out here. In truth, it's probably still deploying. Like we have 100 sensors in all these cities, but the moment it comes through, it immediately starts to show up. And so we're off to the races.
Does your job hosting agent thing, how does this thing interact with something like what you've got here, your schematized? Does this thing just call into like a containerized app? Is there some kind of standard endpoint you've got to implement on your container app and it calls into it, and then that?
No. So it's even easier than that. Literally, the agent gets a certain set of permissions on the machine itself. In this case, it has permission. The default permission is to run WASM and Docker. Okay, so on that machine, it gets a command and says, "Okay, time to here's my job description." And again, this really is the job description. Here's the job description. Go run it. And then in all of these locations, it's going to run. In this case, it's told it's going to run Docker, and here's the here's the container it's going to run, and here's the command it's going to run against that Docker container. Now, you don't need that, right? You could pre-build a container to do something already, and then you don't have any parameters, right? Or you could have it run any other arbitrary binary you'd like. You have to tell it that it has permission, and then, of course, you have to grant it permission on every one of those nodes. But we don't care. We're simply a remote executor.
Oh, got it. Okay. I mean, you basically, the thing that hooks into it is everything is defined in this YAML file, essentially, and that's it.
Exactly right. Well, again, I don't want to overstate. Like, there's in that compute file I told you earlier, we allow list in a whole series of things, and you simply turn on or off what you're going to say. So, for example, it's one setting to turn off networking. Well, I've allowed this thing to do networking because I need it to connect to Cosmos, but it doesn't have to. I could say, hey, you know what? You're going to run on this node, and you don't have any right to do networking. Or you could say you don't have a right to do Docker. Like, all you have a right to do is run sed or something like that, and you could do that too.
Got it. Okay. So the app you've got needs to implement your library, and then, of course, that app needs to have the permissions to be able to do the stuff.
Well, sort of. I'll be honest, right? Like, so we don't have a library. We don't have any SDK or anything like that to run a job. Once the job is on the machine, we run it for you, but there's no special SDK that once the job starts, it ever talks to us again.
Oh, I see. Okay.
Make sense?
Yeah. Okay.
So next thing is that I want to show is, like, again, another configuration change that we see all the time. A lot of folks really forget how much data they're leaking through. Very, very common to have stuff come through that is way too sensitive. In this case, this GPS location is down to the centimeter level, meaning if I got a list, even if I was an internal actor only, and I got a list of these, you now have a layout of my factories, right? Not ideal. I don't need that data in order to do what I'm doing here as far as like general information. I have sensor data or sensor IDs and things like that. So what I really want to do is I want to streamline it, and I want to remove any sensitive data. Now, again, everyone's different. This is kind of a silly example, but like certainly you can imagine if I'm in Europe and I want to move data across country lines, I'm now subject to GDPR regulations. Yeah. GDPR regulation says you're not allowed to move IP addresses, right? Raw IP addresses. You have to drop the last octet. And there are lots of other examples just like that. So that's the general thing that we're trying to get to here. So what I want to do is I'm going to run this new job. This job is called sanitize. And all it's going to do is turn on the sanitize functionality that we already have built in. Again, the only reason I did it that way is just wanted to make it focus the folks on the stuff that I think is the more valuable. And so when I go over here, we have a sanitize processor, like I said, already written. All it does is round to 2 digits. That's all, right? Nothing special, but you get the idea. Yep. So when I go down here and I go to run my, and I go to run my job, sanitize, and just because I don't want to wait during the demo, we're going to go do that. Off it goes, and presto, we're going to run that again and go back over to our data points, and we are going to see right there. So It's already started flowing in. You can see now lat long is just 2 digits long. Does this all make sense?
Yeah. Yeah.
Okay. We are singing along. Now, one of the things I already talked about earlier was the amount of data coming through. Way too much. In this case, right now, our live data stream is showing about 220 megabytes. I don't know what's going on here.
There goes. We had it.
Yeah, see, again, you got to blame me for the UI stuff.
I saw it there for a second, and then it went to 3, and then you refresh it. So it's going to take a sec probably to hydrate again.
Yeah, probably will. Anyhow, that's another thing that you see. You have people wanting to sanitize overall, and you aggregate. There we are. All right.
There we go.
So same deal. Here we want to turn on aggregation. Again, a very common scenario where people want to aggregate their data because in this case we are sending through 1 sensor data point per second. That is 60 per minute. Obviously, as you begin to get into 104, you start to get your numbers pretty large here, right? This is actually over 310 seconds, or excuse me, over the past 5 minutes, we've pushed 310 megabytes. Networks can keep up, but man, you're starting to get to real numbers. So what would be much better is if we were able to aggregate, right? And by aggregate, I mean, hey, you know what? Just average over the course of a minute, as long as it's not an anomaly. Okay. So within this window, we're going to round down or round to this aggregate window. We're going to get a window start and a window end. And then at the end of it, you are going to be able to produce some information, but we're still going to let anything that is an anomaly leak through, right? Because if something is really bad, if it's more than 1 standard deviation away from the core, then we're going to go off and do that. And we're going to want to see that actually happen. So again, going back to our job, we're going to turn aggregate on. Inside of aggregate, it's going to run and again over a minute. So you're going to have to give me a second here because this is going to take a minute to run. And because you're not going to be able to get the first window of new data until the existing window waits.
Got it. So, and I would use this in a similar. I mean, this is a best practice that we tell customers, hey,
absolutely,
you should do a tumbling window or just windowing of your data in here. So aggregate, min, max, median, mean, whatever. In fact, you could even take and jam all of the intermediate data points and shove them in an array. But instead of sending everything over 1 request every second, just send it every minute. You're still going to get better efficiency over a network if you're packing all that crap into a single request versus
absolutely right. Absolutely right. And it, like you said, it doesn't require a lot. And what I'll say is this is one of these areas where it's amazing to me the amount of folks and decisions that don't get made, or that ultimately paralyze people because they don't have it. So we're working with, for example, a solar field generator in Australia, and every one of those inverters is generating data on a per second basis. They need to use that data for predictive modeling, because they want to spin up gas turbines to support if they, if there's suddenly raining or the cloud cover or it's night or whatever, they need to turn on the gas turbines, but they don't want to do it unnecessarily. So they'll do predictive analysis using ML models. The problem is these solar fields have very poor connectivity, right? Because they're over 5G if they're lucky. And so their models actually only require 10-minute windows. So they're moving about 600 times too much data as it stands right now. By doing nothing more than just averaging over that 10-minute window, they're able to actually take much faster responses, because now instead of waiting hours to get the data, when the may already be there, they're able to take much more quick action.
Sure.
And so that's probably enough. Oh, sorry, go ahead.
No, I mean, it makes sense, right? If you have very light throughput or bandwidth and weird latency issues with connectivity and stuff, I mean, just less is more here, right? So
absolutely.
Yeah.
Okay, so there you go. Updated the thing, and now the sensor data maybe too aggressive, but now we're down to less than a megabyte, and I'm sure it'll come up here.
Everything looks good in San Francisco. No,
yeah, exactly. San Francisco, very happy. But it's again, it just starts to add up as you get all these sensors. Like there's no, you're like, well, how much could it be? Turns out it really does add up. And so in this case, we're down to about half a megabyte per minute. So you can see just a massive drop off.
And you're paying for bandwidth to jam gigabytes of sometimes meaningless telemetry over a WAN. You got to pay for the compute to shoot that data once you get it into
absolutely
a hyperscale of some sort. And I don't mean to cut off my own nose, but by the way, we're going to charge you for every data you write into Cosmos. If you don't need it, I mean,
again, it's not the cost of moving the data. It's the fact that, yes, I mean, the cost is just kind of like the cherry on top. It's the fact that it slows everything in order to do this, right?
Yeah.
And it's such a pain in the butt. But there you go. Yeah. So that's what we're doing around aggregation. Let's do one more thing just to see if we can show off here. Again, genuinely shocked that my code hasn't fallen over. Well, let's see how far we can push it. So one other thing that we're seeing here is we have here's our chart with all real live data in Delhi. Our sensor is producing at whatever this humidity and this pressure, so on and so forth. I've highlighted here when you have particular data points that are outside of the normal, that are anomalies, we'll call it. And all I did there was just injected some stuff to cause some problems when things pop up, when they're more than a standard deviation away from the norm. You can see them here, and I'm noticing that these are all they all happen to be firmware 1.2, 1.3, 1.2. That is, I remember that there has been an update of the firmware. So let's do that, right? Let's roll out new up there and see if that can take care of our anomaly. Oops. Firmware. Again, I'll do ID only because I don't want to wait for this to deploy to everything. Off I go. And we'll do a refresh here, and we'll do our scatter plot. And we can now see that as the things come through, the new sensor data is at 2.0, and doesn't have those anomalies in them. So again, very, very, very surprised and impressed that everything's working properly. But so there, I'm not changing the data itself. Going back to that demo, or going back to that diagram I talked about earlier. Window here. Let me just pop over to this. In case number 1, we rolled out a job and changed the way that uploader.dll worked. And then in case number 2, we rolled out and we changed the way the sensor worked.
Got it.
This is a real life benchmark savings where, just on a log collector, lots of folks have issues with their log collection being very expensive. Don't get me wrong. Again, they do a great job, but they do tend to be very expensive. We're able to tap out them moving from $2.5 million a year to just $18,000 a year without any loss of fidelity. They aggregate their data remotely on those remote machines. They process it, and then they move the archive data to a low-cost blob storage. But altogether, just saves them an enormous amount of money.
Yeah, that's great.
And like I said, it's difficult to overstate how much this was enabled by what Cosmos delivered. All the things you saw me roll out here, all the updates, all the changes, all that kind of stuff happened right there in line. Gave me the opportunity to change documentation, or doc formats, add new JSON schemas, things like that. Whatever I liked, I could stick it all here in line, and, greatly simplifying it. And every single one of those sensors went to a local partition, right? So it didn't have to go to.
It went to a local regional replica, right? So that you were using active and writing to essentially the closest local region to where your nodes are sitting, right? So got it.
Exactly.
So you're ingesting as close as you can, which is great. You're not pushing it across a WAN all over the planet. You're using
100%. 100%. And because Cosmos took care of the eventual consistency, that made all the difference. I didn't have to think about how to do master or some kind of global replication. I just said, hey, you know what, Cosmos, get me this, make sure it's available everywhere.
Yep.
And then off I went.
Yeah, and that's another great, right, with Cosmos, right? So if you need to query that locally as well, it's there locally for you. You don't have to wait for any of that. It will converge everything into a primary for us.
Yeah,
that's fine. Usually, we're kind of run in an offline manner anyway. So
and just to stress that, the UI that you saw on me right there, that is going against a single Cosmos endpoint. It doesn't even know that these things are across whatever 700 partitions and so on and so forth.
Yep.
One other thing I want to highlight here, those were not real sensors. Those were, in fact, Azure Spot nodes. So we simulated everything you saw here in all of these regions all over the world using Azure Spot nodes. And our agent ran nearby them in order to deploy and run this.
Yeah, very cool. Love it. This is, I don't know. Episodes like this is why I love my job, right? Like work on a globally distributed database and get to talk to you, David, and you guys operate in this kind of same globally distributed environment. And I believe you're filling a critical need for customers that are also working on growing and building themselves out and having this global footprint. And that's across devices, manufacturing, retail, whatever. It's not just stuff. The cloud makes this possible, but there's it doesn't fix everything, right? You still need.
I couldn't agree. I couldn't agree more. And what I'll say is that too many people think, well, this is too hard, and I got to go think about this in all these various insane ways, and moreover, I don't know distributed compute or I'll deal with that eventually. Look, go and talk to any cloud solutions engineer or whatever, and they're like, look, you should at least be running in 2 zones or 2 regions or 2 something, because, we're happy, cloud's great, but make no mistake, it does go down from time to time. And the moment that happens, you're going to be in really bad, most people don't run in an active way, or even if they did, like figuring out how to deploy these places, figuring out how to distribute your data. That's what platforms like ours and platforms like Cosmos take care of for you. They let you focus on your business, and you can hand off some of these problems to someone else.
Yep, exactly. It's why so many customers run on us. Even Azure itself runs on Cosmos, because we figured out all the really hard problems.
Absolutely.
Distributed data. So.
I love to say, I'm very, very lucky. We did a calculation the other day. We have something like 40 years of distributed computing knowledge on the team. Not me. I'm a negative to that, right? Like, we have more than 40 years, but like by adding me, you're subtracting. And I always like to joke. I'm like, look, you can go and do this. You can go and try and figure out Byzantine generals problem and eventual consistency and so on and so forth. It's out there. There have been academic papers, but like, do you really want to read 40 years of academic research on how to do this right? Or maybe you should use something that does it. It's kind of like roll your own crypto. Just don't do it.
Yeah, don't do it. Yeah. Well, David, thank you for coming on. It took us a while to get this show together, but I'm glad we did it. It was great seeing what you guys are making, and I'm a huge fan. You guys are doing some great stuff. So thanks for coming on. Thanks for joining us. And thank you, everyone, for joining us. We'll see you again next time. So take care. Bye-bye.
Thank you again.